So this lecture is still out of chapter 3. So we'll look at how to name organic molecules, specifically how to name alkanes and alkyl halides. So there's some memorization to do first of all. So if you just have a one carbon chain, right, CH4 is called methane. If you have a two carbon chain, CH3CH3, then that is ethane. And that would be what its line formula looks like. Obviously, there's not a line formula for methane. Propane would be a three carbon chain. And four carbon chain would be butane. So those you just have to memorize. There's nothing intuitive about them. Either you memorize them or you don't. The others, there's something intuitive about them, like five carbons. What would a five-sided figure be called? It's a pentagon. So a five carbon chain is pentane. Six-sided figure would be a hexagon. A six carbon chain is hexane. Seven, prefix for seven is hept. So this would be heptane. So sept also means seven, but it's not septane, right? It's called heptane. H carbons, oct. So a carbon chain would be octane. 9 carbon chain would be nonane. And 10 carbons, so 10 years would be a decade. 10 carbons is decane. Okay, so that's the basis. So you got to get those memorized, otherwise you can't do any naming whatsoever. And naming will be a pretty substantial part of this course. You can guarantee that every single exam you're going to be naming molecules. Okay, so now let's make it more complicated. So now you don't just have a straight carbon chain, now you have what are called substituents. Substituent. And then you also have, so that would be a substituent. And then you have what's called the parent. So the parent is the longest carbon chain. So the way you're going to name these is the parent always comes at the end of the name and the substituent always comes at the front of the name. So you have a one carbon substituent and you have so there's two ways to number this. We can number this from the left, 1, 2, 3, 4, 5, 6. So your parent is hexane. Or we can number this from the right, 1, 2, 3, 4, 5, 6. Okay, so which is correct? Well, you always go with the lowest numbering system. So let me just try to keep track of the rules. So parent is the longest carbon chain. And then you number substituents to keep the number the parent to keep the substituents as lowest as possible. So you keep the numbering scheme as low as possible. So for this first molecule, then we're going to go with numbering from the right and not numbering from the left. So we're not going to do that. So then, so you have a one carbon substituent. And one carbon is methane. To name it as a substituent, you change the ANE ending to YL. So this would be called methyl. And then you put a number to indicate where the methyl is at. So it's a 3-methylhexane. So you always use dashes to separate numbers and letters. Okay, so if we name this one, then your parent is there. And let's see, if we number from the left, 1, 2, 3, 4, 5, 6, 7. So it's a 7-carbon chain, so it's going to be a heptane. And if we number from the right, 1, 2, 3, 4, 5, 6, 7. So if we number from the left, our substituents are at 3 and 5. If we number from the right, our substituents are at 3 and 5. So obviously it doesn't matter which end you number from. But now we have 2 substituents, and they're both 1-carbon chains. So we have 2 methyls. So what do you do when you have 2 methyls? So you use prefix di, tri, tetra, penta, etc. to indicate the number. They indicate the number of same substituents. So in this case we have 2 methyls, so we're going to call it dimethyl. So we would call this 3,5-di. 3,5-dimethyl heptane. So you need a number for every single substituent. Doesn't matter if it's the same substituent, every single substituent gets a number. So mistake students will make, they would just say 3,5-methyl heptane, or so it's kind of redundant. Di means there's 2 of them, 3 and 5 means there's 2 of them, but that's the way it's done. Okay, so for the next one, so that would be the parent. Obviously you're going to number from the right to keep the numbering scheme as low as possible. So 1, 2, 3, 4, 5, 6, 7. So it's another heptane. And 2 methyl substituents. Right, that's a methyl and that's a methyl. It's 1-carbon chain. So in this case it would be 2,3-dimethyl heptane. Okay, so this one's next one's a little bit harder. So that would be the parent. So if we number from the left, our first substituent is at 3. If we number from the right, our first substituent would be 4. So that's all you had to do, is find the first substituent, keep the numbering scheme as low as possible. So we're going to number from the left. So 3 is lower than 4. So 1, 2, 3, 4, 5, 6, 7, 8. So now we have an 8-carbon chain. So the parent is going to be octane. And now how many substituents? So let's see. So that's a methyl, that's a methyl, and that's a methyl. So we have 3 methyls, so it's a trimethyl. And it's a 4,4,5 trimethyl. And then the other substituent is a 2-carbon chain. So that's an ethyl. So on carbon number 3, we have a 3-ethyl. So the next rule in naming molecules is alphabetize. And when you alphabetize, you ignore di, tri, tetra when alphabetizing. So for this molecule, you're going to alphabetize based on M and E. So E comes first in the alphabet, so it's going to come, ethyl is going to come first in the name. So 3-ethyl. and then so dash between number and letter, and then 4, 4, 5 trimethyl octane. So commas between numbers, dashes between numbers and letters. So 3-ethyl 4,4,5 trimethyl octane. Okay, so now we're getting a little bit more complex. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what you might be tempted to do, because all the other ones we've just been going straight across. So that would be 1, 2, 3, 4, 5, 6, 7 carbon chain, but that's not the longest carbon chain. Right? If we did this instead, right, that's a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. So let me see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. I do see another 8 carbon chain if you went this way. That's an 8 carbon chain as well. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so how do you know which one's the parent if they have the same number of carbons in the parent? So we need another rule. So these rules that I'm going through are what are known as the IUPAC. That stands for International Union of Pure and Applied Chemistry. So they're the ones that sets the rules for how you name molecules. So if two chains of equal length, then the parent is the one with the most number of substituents. So if you notice, the orange chain has 1, 2, 3 substituents. And the green chain would have 2 substituents. So orange gets to be parent. So then where we're going to number the orange from, if you number from the top, the first substituent is at carbon number 2. If you number from the bottom, 1, 2, 3, 4, the first substituent is at carbon number 4. So we're going to number from the top. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have a 2. We have a 2-methyl. We have carbon number 4 is a 3 carbon chain, so that's a 4 propane. Will become propyl. And we have a 5-ethyl. And then octane will be the parent. So now we just alphabetize. So 5-ethyl dash 2-methyl dash 4-propyl octane. So, it's, if you have a really big complex molecule, the name of the molecule could be 2 or 3 lines long. You won't see any like that, but if you have complex molecules, they can have really complex names. Okay, so for this molecule, so we introduce ring compounds here. So you have a 6-membered ring. And so one point to keep in mind here is that ring carbons always belong to the ring. So what I mean by that is you couldn't say, well, what about this chain? And the answer is no, because that carbon is a ring carbon. It belongs to the ring. You could not make a 1, 2, 3, 4, 5 carbon chain using that carbon, because it has to belong to the ring. So what you have is a 2 carbon chain here, a 2 carbon chain here, and a 6-carbon chain here. So the 6-carbon chain is the longest, so the ring is the parent. So 6 carbons is hexane. What do you do when it's in a ring? You call it cyclo. So it would be a cyclohexane parent. And then fluorine would become fluoro as a substituent. Chlorine would become chloro. Bromine would become bromo. Iodine would become iodo. And then these are ethyls. So you got 2 ethyls, so it's a diethyl. Okay, so now so in a ring, you always number with one of the substituents. So we could start numbering from here, 1, 2, 3, 4. So we could have a 1, 4, 4. Or if we started numbering here, 1, 2, 3, 4, we could have a 1, 1, 4. So which one's going to be correct? Well, those are the same, so then you go to the next, and this is where you make the determination. 1, 1, 4 is better than 1, 4, 4, so we're going to number in green. So we're going to alphabetize based on E, because we ignore ditri, tetra, and F. So E comes before F, so it's going to be 1, 1 diethyl. And then dash 4 fluoro, and then cyclo. Hexane would be the name. Ooh, okay, let's do 3 more, and then we'll stop and we'll put this last part into another lecture. So let's just get rid of this. Okay, let's name these 3. Okay, so there's our parent, 5-carbon chain. And we have a substituent, so that would be chlorine, would become chloro. And that methane would become methyl. And they're both at carbon number 1. So 1 chloro, 1 methyl. 5 carbons is pentane. In a ring, it's cyclopentane. Okay, and so for this one, 6-carbon chain, so it's a cyclohexane. I just threw this one in, so where do you number from? Is it 1, 2? Or is it 1, 2? So the numbering scheme is the same. Did we have this in the rules already? I don't think so. So if the numbering scheme is the same, then resort to the alphabet to decide where to start numbering. So it's a lot of rules, but they're all very logical. So we have a bromine would become bromo. Iodine would become iodo. So bromine comes first in the alphabet, so it's going to be, you're going to start numbering with this. So 1 bromo, 2 iodo, and cyclohexane. Okay, last example. So what's the parent? So we have a 5-membered ring, and then we have 1, 2, 3, 4, 5, 6-membered chain. So whatever's longest becomes the parent. So the 6-carbon chain is the parent, and now the ring is a substituent. So this would be cyclopentane. So what do you think you do with it if it's a substituent? Just like methane becomes methyl, ethane becomes ethyl, propane becomes propyl, pentane would become pentyl, cyclopentane would become, change the A and E ending to YL. It would become cyclopentyl. So what do we number at from the right or the left? 1, 2, 3. If we number from the left, the cyclopentyl's at 3. If we number from the right, it would be 1, 2, 3, 4. It would be at 4, so we go with 3. So this would be 3. Cyclopentyl. And the 6-carbon chain parent would be hexane. Okay, so that's a little introduction to naming organic molecules. In the next lecture, we'll do some more examples.